working. So okay, as I'm gonna say, I am Alfredo Ortega. This presentation was made by Sebastian Muniz and myself, Sebastian couldn't come, so I'm gonna give a presentation alone. And it's about Fuzzing and Debugging Cisco iOS. There were a lot of talks about iOS, but that is the Apple iOS. This is the Cisco iOS. This actually it's an operating system that runs in a lot of Cisco equipment, routers and macro devices. Actually, Switch also run a form of Cisco iOS. And I'm sure you work in a big organization. There are several Cisco devices in your organization. And people tend to look into these devices as, appliances, things that are not computers, but they actually are computers like any other, and you can exploit them, you can find bugs in these devices, and you can actually debug these devices. This is not a talk about specifically about attacking these devices, mostly like debugging these devices. But we do a lot of demonstrations, basically. Okay, we're gonna talk about first of all the architecture of the operating system. You know the memory layout, all the components of the operating system. This is how we manage to debug the devices. Basically, the good thing that you maybe will find useful about this presentation is that you actually don't need a Cisco device. You can see I didn't bring any Cisco device because you actually don't need one, because we're gonna do everything in an emulator. It's a very known emulator, very common. We're gonna do some demonstration using GDB and using IDA. You see IDA, there were a lot of demonstrations that uses the IDA program for reverse engineering. We're gonna use that, and we're gonna use GDB also. GDB is a free debugger. Then we're gonna do a little review about why you will want to debug Cisco devices, or why would you want to debug any device. For example, it's good to do a self-check or do a check of that what you are doing is actually what you want to run and not malware. And of course, we're gonna do some analysis of a simulated or malware that we actually created and injected in a Cisco device. And a fuzzing example. Fuzzing. There were a lot of talk about fuzzing. Well, you can actually do that with a Cisco device also. We actually make a little framework for you to help you fast and you basically test and make test cases on this operating system. Okay, well, this is the architecture of the operating system. Cisco iOS is actually a very old operating system. It's not modern at all. For example, it's not like modern. It doesn't have a process separation, for example. This is the most important thing. It has a single address space. This means that every process inside actually shares the address space. Basically, if you crash Cisco device, it probably will reboot. It's not like Windows when you can crash individual processes, and actually Windows will not come down completely. But sometimes it does. But actually, for example, Linux is pretty resilient. Linux, every process is isolated, not so much in Cisco iOS. There are newer versions of Cisco iOS actually that are really much better and use, for example, QNX for this. There's some components that actually run QNX. But we are going to study, this version of Cisco iOS that run in most low-cost routers, for example. Routers that you will find in very common organizations. The scheduler is cooperative also. That means that actually you have to give back control to the operating system. They actually are quite primitive, but it actually works. Very similar to, maybe you remember Windows 3.9, 3.1, sorry, 3.1 or 3.11. Okay, well that's actually similar. Of course, it's similar, but not the same, because Cisco is actually a single binary image. You don't have separated modules. Actually, when you download a firmware image, it's all a single binary image get loaded into memory. And inside this image is the kernel and all the services compiled and linked together. Well, you can see here it's drawing. You actually have a kernel and you have a process and you have different priorities, but they all run in the same address space. So if you get to run code in FTP server, you basically can access all of this process. Not really very secure. But this maybe newer version or latest version of very expensive Cisco equipment are really different from this. This is the most common and used on very old operating system. Of course, well, you want to debug this operating system because let's say you are a Cisco developer, or you want to know why your router is running slow, or if your router has been compromised, because a router can be compromised on the computer. And in fact, it's very good to compromise a router because, first of all, you will never think that a router is compromised. And also, every routers tend to see or to look at, to have access to all the communication of an organization. So it's a very good thing to compromise a router. The problem is that it's quite hard to do it. But okay, the first thing that you have to do is to debug it. Basically, you have a GDB server inside of the operating system. A GDB server, you know, GDB stuff. That is basically is a standard protocol where you can debug things. You can see breakpoints, you can write into memory, read into memory. And you can see that it's quite complex. You have several levels in which this debugger can be run. The problem is the debugger inside Cisco devices crash all the time. It's not really stable at all. It's very difficult to use. It's not standard actually. It's basic in a standard, but it has so many modifications from Cisco that you actually cannot use anything to connect to it. You have to use a very old version of GDB that has support and like patched by hand, and actually even then it will crash constantly. It's really a hassle to use. But and of course you need a real device to use it. That's why it's very good if you can use an emulator and you can connect to the emulator. Basically what we did was to modify the emulator. It's gonna do the next slide. Well, this is the emulator I was talking about. Basically we pick up this emulator that is a very, very good emulator. It was made by this guy that actually is excellent work because it emulates all these devices perfectly. But no, not exactly 100% emulation, but it's a good enough emulation that you can actually run a router and use it in your network the same way of a real router. You can actually download a firmware and run in this emulator. It will run perfectly. So it's great because you don't need a physical device. It will run in every operating system. It actually has a user-type compiler, so it's not really slow, it's actually quite fast. In some kind of cases, it's actually faster than a real device. So, for example, this is one of the lowest, the most cheaper router from Cisco. You can actually run much faster than a real router on your computer. It implements everything from the CPU. Cisco, basically, they have two main architectures. They use MIPS architecture and PowerPC. MIPS architecture are used in the bigger ones, and the lower end routers, they use PowerPC basically. This is PowerPC. And the bigger ones, they are basically MIPS. They support lots of models. Of course, they don't support all the Cisco models. It actually, if you compare this with all the models that Cisco has, they're actually a very, very small part, but they're quite helpful actually. The problem is this emulator really didn't have any debug support. So it was great. It was a great piece of software that really lacks like the best part of it, a debugger side of to analyze the firmware. So basically we just add that. We just place this little module here, you can see in red. This is a little patch, not so little, but it's basically just a patch for the emulator that allows you to connect to it with any standard GDB client, for example, GDB itself or IDA Pro. And it's actually standard, so it will run with any client. We had to, of course, modify the CPU implementation to allow for control register and memory. And when run this debugger, you can use JIT or just-in-time compiler, because you actually have to execute instruction by instruction, and that is not really compatible with the just-in-time compiler that just get a bunch of instructions together, just compile, united code, and runs. So actually, if you run this GDB server, you have to deactivate the just-in-time compiler. But if you have a fast computer, actually, that's no issue at all. Well, we actually didn't implement a lot of commands. At this time, we implement only the basic that you need to do a debug session, like write register, memory, and breakpoints. GDB actually has a lot of commands, like over 100 commands. I think we implemented like about 90, but that is actually enough, and it will work very good. Okay, and last, the good thing is that you can use any GDB client. You can use the free GDB client. It will work with no modification. I'm gonna show you right now. The thing that we didn't modify and we really can debug at this time are all the special hardware. You know, a router has a lot of special hardware, not only network devices, memory, and CPU. They have many hardware devices. For example, they have FPGA controller for controlling stuff. They have although they can plug cards into a router, and they usually have their own subsystem. And we actually didn't touch all this. You actually, at this time, you cannot debug this part of the router. But the good thing is, this is a very small part of the functionality. The main operating system, the main Cisco IOS, it has a huge image. It's about 30 megabytes. It's completely accessible from the debugger. And also the bootloader. I'm going to show you the bootloader is like the BIOS of the router. You can actually debug the bootloader. So, what is cool about this? Well, what I most like about it is that it's actually cheap. You don't need a router. Why? You don't need a router if you want to break the law, actually, because maybe it's not completely legal to run Cisco IOS if you don't have a router. You have isolation. That is good if you are analyzing malware, because if you are analyzing malware in a Cisco device, you're going to see, you can analyze anything that has been compromised from the inside, because of course the malware will just actually can make itself invisible to the debugger. Unless you have isolation, you have a virtual debugger. That's like this. Well, you have a controlled debugger environment. Basically, you will run every time the same, because it's completely emulated, and you won't have any problem with stability or all kind of stuff. It is bug-handler friendly. It means that because it has a controlled debugging, if you find a bug, you can actually reproduce a lot of times. And it's quite hard to do with a physical device that you have timing issues, you have a lot of issues, and they are actually very, very difficult to reproduce your work. Now, the problem is, of course, it's only emulation, it's not 100% exact. Specifically, you can the Dynamics doesn't emulate the cache memory or cache effects of the CPUs. The MIPS and PowerPC CPUs are very picky with this cache. You can, for example, it's very hard to do auto-modify code self-modifies. So you can emulate exactly, but you have a pretty good emulation, let's say. Basically, if you have something working in the emulator, if you then go to the physical device, chances are that it will work. Well, basically, it doesn't support all hardware models, and of course, you need your own legal iOS image. But depending on the country that you are, you maybe don't have any problem. You maybe you will need a Cisco device, or maybe you will need to work for Cisco. I assume you all work for Cisco, so it's okay. Or maybe you can get a job. Like, if you want to use this. Okay. So one of the good things is that we can actually isolate the debugger pretty good. This is a case when that's when you have a virus on your computer, you actually have to reboot or you have to unplug the hard disk and analyze it in another computer. Because it's actually pretty basic. You can analyze anything that's been compromised. The malware can just show you that can just send fake bytes to the analyzer, can you send fake information, because malware actually have control of all the device. So you actually, if you are trying to see if your router has been compromised, of course you cannot ask the router, because the router will say, no, I'm not being compromised. You never will see, you will answer yes. And when you run in an emulator, the malware is actually isolated from the debugger or an analyzer. So this way, there is no way the malware can hide itself from the debugger. And this way, the malware can very easy to hide. So there were problems many years ago about malware in Cisco devices. And Cisco actually published a handbook about how to verify. So you can look, you can see it very well, but this is an URL about, it's a handbook on how you verify or a chain of, you follow a chain of trust when you download a firmware image and you flash it. Actually, pretty good, most of it. The problem is there are some parts that are actually they are not really well explained. For example, this section, it seems to be that Cisco guys are telling you that you have to verify an image after you load. And of course, you cannot use that. You have to verify an image before you see. You have to verify a software that's loaded on a device. But no, you have to verify before. Or before of this already in the device, you can use something like this, isolated. Because you know the malware will just hide itself. You will say, yes, I'm good, I'm not on. But you will see that. But okay, this is not really clear. If you have to run the verify command in a compromise, before loaded or after loaded. Of course, you have to do before you flash the firmware into the device. Well, so that is what I was saying. You really can have a self-checking routine, and even if the operating system doesn't have any isolation, it's actually impossible to have a correct working or a self-checking routine that you actually can trust. Basically, well, there you have. This is a malware controller SyScan'11. And of course, you will ask the firmware to verify itself, and it will say, okay, I am perfect. It will return MD5 checksum. That's what actually you use. And it's fake because it's controlled by malware. But if you take the firmware from outside and from your computer and you do the check externally, it actually will work. Then again, you will never verify your code in an infected host or not non-trusted host. You have to trust your host. Because of course, if you don't trust your computer, you can verify it. You can use it to verify anything. For example, we're gonna see an example now, a demonstration about how you will use IDA Pro to debug compromised iOS installation. We actually injected a backdoor in this firmware. Of course, I don't want to present any new vulnerability or 0-day. This is all emulated, so you please don't freak out. This is only we injected just to show you. But this is a very nice, very good way to show you. We're gonna see how you can use it. IDA is actually very nice to use. Let's see. I think I have it right here. Basically, you go here. Sorry. Okay, we have our script here. The emulator is a command line program. Actually, it doesn't have any view, so you have to run it from the command line. I am using Linux, but you can use whatever operating system you like. You call it like this, Dynamics. This is actually a patched version of Dynamics, of course. The model number. This is a parameter it doesn't get so much CPU. Network, debug port, and of course, this is the firmware image. You see, this is the firmware with the backdoor. Let's activate the network. There we go. And let's run the emulator. I'm sorry about this. This is because I'm using one. Actually, it doesn't work very good. Okay, this run. Okay, the emulator run. The Cisco is not booted yet, but you can see here. The server is listening on port 23.946. This is a TCP port. This is a GDB stub, a GDB server listening into this. So we're going to connect using IDA now. Let's see if it works, because IDA tend to not work. Here we specify the port. Okay. Let's try to attach. Yes. Something slow. I have a very slow computer, so if you have a newer computer, you can expect it to be much faster than this. So, okay, we are attached now. Let's hit go, running. So, currently, the router is booting. You can see launched iOS image, memory allocator is booting the Cisco software. It will take a little while, about 3 seconds to boot. But it actually, if you, it's a 1700, you can see here, 1720 router. You can emulate bigger routers, but they're actually more slow than like this. Okay, we're here. So we are running firmware image backdoor. So let's see. The backdoor I want to tell you beforehand. Backdoor is in the login procedure. So let's trigger the login procedure with telnet. We're gonna do a telnet login. I know the IP of the router is this. Is actually a tuned device. It's running all emulator in my computer. There you go, access verification. We can log like anything. The actual password is T1, and you can see here, IDA asks just stop because I placed a breakpoint beforehand. It has stopped just in the password check function. I know this is the password check function. You can see these are not these are PowerPC instructions here, because we are actually looking at the firmware, and we can debug using step by step. And we are debugging here the router. Step by step, you can see the register at the side, and the router is actually running. And let's see. We can continue to look directly at the firmware. The firmware never knows that's being analyzed because it's totally virtualized. But for example, let's go to this area of memory that I already know. You have to, you might spend months looking for all the firmware, but I already know that in this area of memory, I don't know if you can read it actually. There is some very suspicious strings here, like IDA. There are some strings using for some code. See, this is very strange. Let's continue. And probably SyScan 2011 is using a comparison here. SyScan. Okay, so let's try it again. Let's try this time the enable. We're gonna use this password here. SyScan 2011. Copy. Paste. Okay. It just up again in the password checking function. So it's gonna hit play. Oh, factor login activated. We actually log into the router, but using the factor password. So we actually can analyze directly the assembly code. This is a way you can use IDA, for example. And the router will keep running like you can issue any other command. But of course we use we can analyze the factor this way. Okay, let's quit this and let's continue. Quit. Let's go. The router keys keep working here. So, okay, it's just unplug and IDA Pro hang a bit. It's not hang, but Citra, of course. But that is. We just analyze it using IDA. For the next demonstration, we're going to use GDB because I actually like GDB much better. You can see IDA is much nicer with all these functions, but you can see it in this way that is actually beautiful. But I actually prefer much GDB to do all the analysis. Okay, so let's continue. One cool thing about the debugger is that we actually can debug the ROM mount. The ROM mount is like the bootloader of the Cisco device. It's actually not a small program, it's actually quite big. It contains a lot of code. You load the firmware for a lot. You can load from the network, for the flash, for external file, for internet, FTP server, tiny FTP server, right? There's a lot of ways you can load the firmware. And you could actually can be debugged by dynamics. So let's try it. Let's try if it works. We can debug the bootloader. Let's go. I think I have it here. Yes. Just a minute. Okay, you can see here, you actually have to pass the bootloader code to the dynamics and the firmware. Also, you have to pass additionally the code that the bootloader. You can dump the code from bootloader from the Cisco device, or you can. There are some firmware updates that also have a bootloader or microcode embedded. So basically, we just run. So now the HTTP is listening in a different port, but we also have a microcode, about running a microcode in memory. So now I'm going to use GDB. It's a GDB especially compatible for PC because only has for PC. And let's gonna use a script. I'm going to show you what I'm going to execute right now. Basically, you can actually run a world untouched bootloader because bootloader really accesses a lot of hardware that actually is not yet implemented in Dynamics. So basically, we use the debugger to modify in memory this bootloader so it can actually boot. So you have to do a little of skips initialization of memory and another devices, but it actually with very little modification it will run. Yes, let's do it. There we go. Okay, so we can see here, this is actually loading the boot value of Cisco. This, the first demonstration didn't have all this string. This is actually all debugging strings, our booting strings. If we continue to boot, you will think they have 16 megabytes of memory. And of course, we hit a breakpoint, we can debug like any other code. And if we continue, of course, the flash image is not in the firmware is not in the flash image. I still don't have emulated the flash device. So actually the boot device will stop there. After we had to do a little more hacking so it can load the firmware directly from Dynamics. But the cool thing is you actually can debug without any problem, you can debug the bootloader, and also you can, as you can see here, it just crashed. It's not really, it has some bugs yet. You can actually, want to show you that you can actually modify the bootloader this way. I have just load a modified version of the bootloader, and we can emulate the same way. There we go. You see, now the bootloader is running, but they have this string that is I'm the bootloader. The thing is you can execute code in the bootloader. It's actually much better than you can do if you can execute in the firmware, because the bootloader never changed and is actually there are no many upgrades for the bootloader. In fact, some device you really can't update your bootloader. So if you manage to place bad code there or malware in your bootloader that will, for example, automatically patch the firmware, you basically you have to throw the device to the garbage, because actually it has a very good it's a very good attack. The thing is, this is all emulated, and actually I never tested this bootloader modification in a real device, because some devices actually you will have to remove a chip to do it, remove the chip directly. But well, now you can modify the root mode of the bootloader of the Cisco. That's actually something that never have already done. So there you go. Let's continue with the next demonstration. Okay, let's do a little bit of fuzzing. Fuzzing like doing test cases and throwing them to the Cisco. We can do it this way. We only need the most important is we need a correct exception handling. So our debugging must catch all the exceptions. We must catch, for example, memory access exceptions, and basically any exception that is a bug or can access wrong part of the memory, meaning that the router have crashed. You have to catch it. You have to have a good subsystem for the debugger to step right before the exception happens, so you can analyze what caused the exception. And of course, you have to log, because once you find a crash, you will have to try to reproduce, so you can fix it or you can attack it. Okay, so I did a very little fuzzing framework for Cisco. It's actually very basic. You can see here the fuzzer is a Python script. It's written in Python. It's only 100 lines. You start GDB, start Dynamics, basically start launching. This is an FTP fuzzer, because it's the easiest protocol and only for a demonstration. Basically, you start throwing commands at it and test cases. If Dynamics detects an exception, you will tell GDB and you will say what was the cause of this exception, and we'll keep trying every command with every input until it ends. actually is quite simple. Here's the state diagram. You can see there's nothing special. Basically, you connect to the FTP, you launch a command with a wrong argument. It's the dumbest of the dumb fuzzer you can do. If you crash, basically you save, and if it didn't crash, you just test another command. FTP after about 30 commands, so it's actually very quick. I think you cannot do a simple fuzzer like this. It's actually quite stupid, but it's only for demonstration. Let's see. Okay, this is a quite complex demonstration. So let's see if it works. First we're going to clean every process that we may have. Let's run. And for this, we will need to run the Python script. Faster. You can see, actually, the Python script is a GDB script, because you can script GDB in Python. Let's see if it works. It will take a while. Basically, now the script has started dynamic, so it's waiting for it to boot, because it actually takes about a minute to boot. So the debugger here is, sorry, the fuzzer is waiting for the Cisco image to stop booting. You can see the screen numbers is the delay that the fuzzer is waiting. You can see this all the messages. We actually already saw this message because it's the same that we saw the first time. Okay. Let's wait a little longer. The fuzzer will actually access the console and will configure the FTP server. So if it works, the fuzzer will configure the FTP server and will start launching commands to it. And if it crashes, then it will work. We will just save the crash. Let's see. Let's cross the fingers because this is actually quite difficult. Well, then you enable the FTP server, and this is all the commands. And we started to test all the commands. You can see we sent, oh, but it don't give me much time. Actually, it already crashed. You can see when you use this, you do this command, it actually crashed. It actually, you can see we overwrote and stuck, and we actually control all these registers, and we also output where the crash was happening. It's actually a branch instruction, so we actually control the program counter, and actually we keep with the fuzzer. It takes about 10 minutes to end, so I really don't want to show you about it, but that's it. You will try every command with a big letter. We can already see that we crush in the third step. So what we found with this, okay, this of course is not a 0 day. This is already patched because this is a very old firmware image, but you see this little fuzzer, it crashed actually all these commands. User, this is our FTP commands. It actually crashed the help command. How you can manage to crash with a help command? This is like the simplest thing. And actually, the only way they can fix it is to completely remote. You don't have any FTP server. I think that is a good. Actually, remove and ensure you fire the employees because you cannot screw it like this. And you will see, oh, this is only a single bug that affects all the instructions. No, we found like 6 different bugs that are, of course, patched, but removed actually. So you can see this actually not really how to crash a network device because we didn't propose the easiest fuzzer that we can find, and you know, we keep finding crashes and crashes and crashes, and they're completely exploited. Actually, if you look internet, I think you can find an expert for this very bad. So you can can see here, well, I have a debugger that I can use in a production environment because it's quite secure. You know, you don't have malware that can attack you. Well, the problem is Dynamic has bugs itself. The emulator has emulating bugs. So it's not completely safe, it's not completely isolated. The only way you can isolate software is, I don't know, put it in space, you know, in a Faraday cage. Actually, it's a lie that you can isolate completely software, even if you have a virtual machine or an emulator. And actually, we have a demonstration about this. I'm going to show you right now. When this stops. Okay, please stop. Doesn't work. This, we have to run an old version of Dynamics because we are really patched this bug. The problem with Dynamics is actually not maintained anymore. So, if you go to the site, the latest version is actually very old. Okay, we are running here an old version of Dynamics. Well, actually, it's the latest version. It's not old, it's only not patched. This is the latest version of official Dynamics version. And we're actually going to attach, put to the Dynamic itself in my computer, not to the Cisco router side, but to Dynamics. Let's see it. This is the process. You see, this is the common GDB. I'm not using this page. Okay. So we are debugging Dynamics itself. So let's go delete those. Oh, there we go. Probably. There you go. Okay, we now attached to the Dynamics router, and we'll try to trigger this bug. We have to send commands directly, so we can use FTP. We must use telnet. There you go. So, have to access the FTP server because I have to enable this, of course. You see, I'm issuing directly comments to the FTP server. There you go. Let's launch this command. I know that it's the command that will actually make the router to crash. It's not very hard to do it. You can see it. Crash. Apparently it crashed, but what happened? Well, the crash was Dynamics, not the router. Dynamics itself has crashed. So you see, what is happening? Because this is a bug in the emulation code. You can see I have Dynamics combined with symbols. You can see the source code. And if you look at the variables, for example, this variable, this is the address. You can see that I actually control one of the variables that make the Dynamic crash. But not the firmware, but the emulator. I actually, if I can exploit this, I can execute code in the host machine, not in the router. In fact, with this bug, I can execute code in both, not only in the router, but also in the host machine. But actually, I don't know if this is exploitable. Probably it's exploitable, but maybe not in the latest Linux. But it's actually a bug and actually made Dynamics to crash. So it's not completely isolated. You can actually make the emulator crash. So that's I can assure you that you won't get owned. You But with time, we must patch bugs. In fact, this bug was already patched. If you download the GDB version, the GDB patch, it's already, we already also patched this bug so it wouldn't crash anymore. So, okay, what you can do with this? Well, funny bugs, of course. The guy that attacks you with Cisco router, it's very hard to for him to realize that he's attacking an emulator instead of a router. You can do a kind of you can analyze malware with this. That is very hard to do if you don't have this. But you can see you can use IDA, GDB, whatever you want. You can do an expert development also, but of course you have restriction because basically that 1% that is not emulator is the part that will make you expert file because expert are very picky with the emulation, specifically with the CPU emulation. And you have things like cache coherence, cache coherence are actually not really good emulator right now. So you can do expert development up to a point, then you have to test it in a real device. I was have to test it in a real device. Well, this is what we should do in the future. We have to do the exact memory behavior. So once almost every virtual machine has a problem. You can see there's a way to detect virtual machine. VMware does this, there's a lot of virtual machines. They don't duplicate the exact memory behavior. And Dynamics is the same. And once you have all these bugs and all this squash, you actually can make a secure host isolation. The problem is you never know when you patch all the bugs. So basically, I will not sing, sign, or put my hands in fire, as we say in Argentina, for Dynamics. You have bugs. Of course, it's much safer than using a real device. So okay, this is when the tag ends. If you have any question, you can download right now the patch for the Dynamics from here for this URL. You will have to apply the patch to Dynamics. It's actually quite easy to do if you handle open source projects and all this kind of stuff. You have to recompile it. It will work in OS X, Linux, Windows. Probably you have also the scripts that I use. Also you can download from this page, so you can test by yourself. I'm right in here. I think that's it. I don't know if we have any questions.
Does anyone have any questions? Mike's off there. Questions? No? You sure? Okay, Alfredo, thank you very much. Awesome. Okay, we'll have a coffee break now. We'll come back at 4 o'clock for the last talk of the day. Please remember to fill up your feedback form and your membership application form from AISP. All right, we'll collect it from you later. All right, so go for a coffee break. Come back at 4. Thank you.